In this video, we'll talk about the XFS file system. How to maintain a XFS file system. I'm going to describe the btrfs file system as well. XFS. The XFS file system was designed and created by Silicon Graphics Inc., SGI, and used in the IRIX operating system, and it was subsequently ported to Linux. It was engineered to deal with large datasets for SGI systems, as well as handle parallel I/O tasks very effectively. It can handle up to 16 EB exabytes for the total file system, up to 8 exabytes for an individual file. High performance is one of the key design elements of XFS, which implements methods for allowing DMA, direct memory access I/O, guaranteeing an I/O rate, adjusting strap size to match underlying RAID or LVM storage devices. Unlike other Linux file systems, XFS can also journal quota information. This leads to decreased recovery time when a quota-enabled file system is uncleanly unmounted. Furthermore, the journal can be on an external device. As with other Unix and Linux file systems, XFS supports extended attributes, btrfs. Maintaining an XFS file system is made easier by the fact that most of the maintenance tasks can be done online, i.e. while the file system is fully mounted. This includes defragmenting, resizing, enlarge only, dumping, restoring. Backup and restore can be done with the native XFS utilities, XFS dump, XFS restore, which can be conveniently paused and then resumed at a later time. Because these utility programs are also multi-threaded, XFS dumps and restores can be accomplished very quickly. The traditional quota commands can be used to manipulate per file system quotas on an XFS volume. However, if you use the XFS quota command, you can use the per directory quotas that XFS supports. The XFS file system does not directly support hardware or software snapshots. However, the XFS freeze utility can be used to quiz the file system to allow for a snapshot tool to work on the underlying device. The Linux LVM tools will automatically use XFS freeze to quiz the file system for snapshots. btrfs. Both Linux developers and Linux users with high performance and high capacity or specialized needs are following the development and a gradual deployment of the btrfs file system, which was created by Chris Mason. The name stands for B-tree file system. Full documentation can be found on the btrfs wiki page. btrfs is intended to address the lack of pooling, snapshots, checksums, and integral multi-device spanning in other Linux file systems such as ext4. Such features can be crucial for Linux to scale into larger enterprise storage configurations. Well, btrfs has been in the mainline kernel since 2.6.29. It has generally been viewed as experimental. However, some vendors are using it in new products, and it is the default root file system on SLES and OpenSUSE. One of the main features is the ability to take frequent snapshots of the entire file systems or sub-volumes of the entire file systems in virtually no time. Because btrfs makes extensive use of call techniques, copy on write, such a snapshot does not involve any more initial space for data blocks or any I/O activity except for some metadata updating. One can easily revert to the state described by earlier snapshots and even induce the kernel to reboot off an earlier root file system snapshot. btrfs maintains its own internal framework for adding or removing new partitions and or physical media to existing file systems, much as LVM, logical volume management, does. Before btrfs becomes suitable for day-to-day use in critical file systems, some tasks require finishing. For a review of the development history of btrfs and expected evolution, you can see this kernel development webpage. Okay, this is the end of this video. Thank you for watching. I will see you in the next one. Bye for now.